Hello friends, today I will discuss the capacitor start induction motor. In this video, I discuss the necessity of the video, operation of this, construction of it, vector diagram, torque speed characteristics, applications of the induction motor. First, let me consider the necessity of the single phase induction motor, that to start capacitor start induction motor. In a single phase induction motor, normally only main winding will be present. With the main winding, it is not possible to have the starting torque in the single phase induction motor. The characteristic is as shown below. So with a single main winding in the single phase induction motor, the torque speed characteristic is like this. This is the speed versus torque. At the zero speed, means when the slip is 1, the torque is 0. So if the torque is 0 means this induction motor, single phase induction motor, is not self-starting. So in order to start this, we need to add another resistance or another winding to get the starting torque. To get that starting torque, another winding called the auxiliary winding is connected in series with a capacitor and also in series with a centrifugal switch. In this single phase induction motor, mainly there are two windings. One is called the main winding, the other is called the auxiliary winding. This is called the auxiliary winding. The construction of the winding is such that it is a thick wire, and whereas the auxiliary winding will have the thin wire, means high resistance, low reactance, whereas here low resistance and high reactance. And this is the centrifugal switch, and this is the capacitor that is used in this motor. Normally the main gauge winding turns, the gauge is 12, whereas the gauge of the auxiliary winding is 14. Initially, this centrifugal switch is closed with this when the supply is given to this motor. And here this is the rotor, and that too it is a squirrel cage rotor. And this is the stator consisting of the two windings. One is called the main winding, the other is called the auxiliary winding. In this auxiliary winding, the current that flows here is called the starting current. This is also called the auxiliary current, whereas the current that flows in the main winding is called the IM or main current, and the total current is vector sum of the starting current, that is auxiliary current, and the main current. Once the supply is given to this motor, the starting current, that is called auxiliary current, will lead the main current by 90 degrees. As a result, torque is produced. Once the torque is produced, the motor starts rotating. Once the motor starts rotating and reaches 75% of the rated speed, then the centrifugal switch automatically opens, and the vector diagram is as shown below. This is the auxiliary current. This is also called starting current, whereas this is the main current or main winding current, and this is the applied voltage. The angle between the starting current and the main current is alpha, and that is equal to 90 degrees, and the capacitor that is used there in the auxiliary winding is electrolytic type, and its value is 250 farads. Once the motor picks up to 75% of rated speed, then the centrifugal switch opens so that auxiliary winding is disconnected from the circuit, and the rotor continues to rotate in the same direction as before. So here is the torque speed characteristic. So this is the slip 1, and speed of the induction motor is synchronous speed. So here when the speed is 0 and the with the only main winding, the torque is 0. Once the starting winding is connected in series, across the supply in association with the main winding, then the initial torque, instead of 0, it will be like this. It's more than rated torque, that is 3 to 4 times the rated torque is produced at the beginning, like this. So with the both the main winding and auxiliary winding present, and once the rotor reaches 75% of the rated speed, like this, means like at this point, then the centrifugal switch automatically opens. In that condition, there is only main winding present, so the main winding will provide a lesser torque like this, and this is enough to continue the rotor to run like this. So the motor runs with a torque speed characteristic like this. Up to here with both the windings, and after this only main winding is present, so the main winding torque speed characteristic will follow like this. The disadvantage of this motor is that there is a centrifugal switch and there is a electrolytic capacitor. So and there is a auxiliary winding associated with the motor. So the initial cost of the motor is high. And the advantages with this capacitor start induction motor is like this. It has a very high starting torque, as we saw on the torque speed characteristic. It is approximately 3 to 4.5 times the full load torque, whereas the starting capacitor must be large. And the starting winding resistance is low to obtain a starting torque. And to get the high starting torque, we need the large capacitor, that is 250 farads, and the short time rating of the capacitor is needed for starting this motor. This motor has the good starting and running characteristic. In this motor, the starting current is small as the auxiliary winding resistance is high. So the starting torque is high in this motor, and as the starting current is small, so the auxiliary winding will heat up less. And the advantages of the capacitor run or capacitor start induction motor is like this. One is for driving the pumps and compressors. The other is it is also used in the refrigerators and air conditioner compressors, and it is also used for conveyors and machine tools. And this motor is used where the starting period is either small or prolonged. Let me summarize once again the capacitor start induction motor. So in this video we have seen the necessity of the capacitor start induction motor, and we have seen the construction of the single phase induction motor, and we have seen the operation of this and vector diagram of this, and the torque speed characteristics, advantages and disadvantages, and we have also observed the applications of this single phase capacitor start induction motor.